Question 9 is another limiting reactant problem, and we can approach this problem very similar to the way we approached one of our previous problems. Now again, before we can do anything here, we have to balance the equation. But what we can then do is take each of our starting materials, both the P4O10 as well as the water, and figure out how much phosphoric acid, H3PO4, can be formed from each of these starting materials. So in both cases, we're going to start out with 1 mole of whatever starting material is. For P4O10, that has a molecular mass of 284 grams. For water, that has a mass of 18 grams. Now we're looking at moles of the starting material. We want to convert moles of starting material to moles of product. So in both cases, 4 moles of H3PO4 will go on top. And then the corresponding moles of whichever starting material we're looking at will go on the bottom. So for P4O10, that's 1 mole. And for water, that's 6 moles. Finally, to get to the mass of the product, we're going to multiply by the molar mass of phosphoric acid. And we can calculate that out. We find that that's equal to 98 grams. So finally, we can multiply all of this out, and we find that the 100 grams of P4O10 would allow us to form 138 grams of the product. However, the 25 grams of water will only allow us to form 90.7 grams. So that tells us that the water, since it allows us to produce less of the product than the amount of P4O10 we have, the amount of product we can form is 90.7 grams, and the water is our limiting reactant.